Recently came across a new phenomenon relating to the phases of the moon and how they do something really unexpected in the sky. Or, as the Flat Earth Society will tell you, how science has lied to you. Maybe not. Before we go there, let's look at the phenomenon in question a little bit and see what we're talking about. When I first encountered it, I didn't know what was going on, and I found it really surprising. So what did I do? Do I immediately assume that science is lying to me and it's all a big conspiracy? Or do I look into the matter a little further and see if we can figure out what's going on? Here's the background. I was trolling the Flat Earth Society webpage, as I sometimes do, and I encountered what seemed like an innocent enough question from evidently a new flat earther asking innocent questions about how the phases of the moon work in a flat earth kind of a way. Usual debunking responses and whatnot, but then there was a flat earth member himself who posted this. This is evidently evidence that the moon is self-illuminated, and he's got a YouTube link explaining it. What's the problem here? The moon does not point at the sun. Okay. I'm like, what? The moon does not point at the sun? Of course the moon points at the sun. So this really surprised me. I didn't know what to do with this. So I looked into it. I followed this link, and this individual reposted later that he didn't like this link. Not like that link. And he posted a different link. So I'll include that one. So I'm just going to type in here, moon doesn't point to sun. Let's see what we got. Okay, interesting. Lots of different stuff. I've pre-selected some that I think show the phenomenon really well. This one, moon reflects sun's light, impossible. And here's one, the flat earth one. And I didn't find it, but I also have this other one. So let's go to the first one. This is the impossible link. We'll let that watch. What we see is this, the moon seems to be pointing this way. It's about a half moon, and it's pointing upward and to the right. And then he's going to pan over in a minute here and show us where is the sun. Let me just fast forward this section here really quick so we can find the sun. Okay, there it is. The sun's down on the horizon. So we're really incredulous here. The moon appears to be pointing upward, but the sun is clearly down below the moon. So that's mysterious. So here's another one. What is this? Moon shadow wrong angle. Okay, so we start on the sun here, and then we pan over, and there's the moon. And it's kind of hard to see. So once he zooms in, you can tell, again, the moon is pointing very upward here. It's pointing way up, but the sun seemed to be, in this case, like maybe parallel, maybe a little below. So again, the moon is pointing above. So what's up with that? And then here's the one that was linked. It was linked to me directly. And once again, you see the moon is half lit. It is pointing upward and to the right. So where's the sun? By now you could probably guess that we're seeing a pattern here. The moon is pointing upward and to the right, but the sun is not upward and to the right. It is down and to the right. It's over here on the horizon again. Way low, like maybe even below the horizon. Okay, so what is up with that? We cannot argue this is mysterious, right? This really seems strange. Now, somewhere in your early education, you may have seen a demonstration like this. Maybe your teacher did something like this to show that if you represent the Earth here, teacher represents the Earth, this is the moon, this is the sun, and as the moon orbits the Earth, the side that's facing the sun looks different to you. And that's what causes the phases of the moon. So here we have a new moon. Actually, we're going into an eclipse. There's an eclipse that ends. And then we'll go to a crescent moon. And then as she continues turning, there's the, I'm going to call it the half, but you know, the quarter moon, of course. There's the gibbous moon, of course. This all makes perfect sense. And it really seems to make a lot of sense. You know, when you're in school and you see this for the first time. But now we're faced with a real puzzle. We just saw a bunch of videos where the lit side of the moon didn't seem to point towards the light source. In this demo, the lit side of the moon just points straight at the light source, and there's just no way to reconcile that. These videos clearly show something that sure looks like the lit side of the moon is not pointing at the light source. But our teacher said that it was supposed to. So how can this be? Our teacher taught us that the moon, the lit side of the moon, has to point back at the sun. It has to. And yet we've seen these YouTube videos that seem to suggest that it doesn't. And indeed, if you go outside and look for yourself at the moon, it sometimes looks like the moon is not pointed towards the sun. And, well, something's wrong here. So, was the teacher mistaken? Teacher is just wrong about all of this? Maybe we've discovered something new that no one else knows? Or maybe your teacher did know and deliberately is trying to trick you. Or maybe there's just some detail that you've been overlooking. Something that maybe the teacher didn't cover in that lecture that explains this, but you don't immediately see what that could be. When you first learned science in school, did you simply accept these lists of facts? You memorize the facts and you regurgitate them on your exam and you pass the class and you move on. Is that what you thought you were supposed to be doing? Did you think that science class was just a list of facts that you were supposed to memorize? If so, you missed out. You really missed out on why we believe these facts, why these facts can be proven to be true. How do we even tell which facts are true and which are not? That's really the core of what science class is supposed to be. And if you missed it, you missed out on something really important. So then later, you do discover something. You encounter someone on the internet who points out something that seems to contradict these facts, seems to prove that what you believed before isn't right. Do you now simply accept their word for it? I guess we have two competing versions of the truth here. We have your teacher's version and we have the internet version, and how are you even going to choose which one to believe? Really, that's your failure all along, is choosing to believe. Facts are based on evidence and reason. We don't simply get to choose to believe them or not. If we're going to start using critical thinking, I think we should begin with a solid foundation. Let's start with a few simple rules. I do not know everything. Everyone is biased. I will consider evidence from multiple sources. Facts can be verified and replicated. I will not blindly accept interpretations from anyone. And sometimes the truth will be unexpected. These don't seem particularly earth-shattering, but this is time and time again where I see people failing with critical thinking, making blunders with these simple rules. When you see something that doesn't seem right, by all means, be skeptical, but recognize you don't know everything. And this last one, that's kind of a paraphrase of something Neil deGrasse Tyson likes to say. Just yesterday, I was listening to a very prominent flat earth evangelist as he was going on about this, and he was making fun of this. He was actually mocking this statement. He seemed to be saying that anytime something doesn't make sense to him, that means it's wrong. That he seemed to be implying that the universe must make sense to him, or else it was not possible. It was not possible that there was anything about the universe that he doesn't already know. And it was not possible that anything in the universe could ever surprise him. Keeping these rules in mind, let's apply some critical thinking to the problem at hand. So I guess these days, go-to place to begin researching pretty much anything is, well, let's Google it. Moon doesn't point at sun. Before we dig into any of these links, let's remember, not all of them are going to be true. Not all of them will be relevant. Some of them may disagree with each other. To make any use of this at all, we're going to have to bring our critical thinking skills with us when we do this research. We're just looking at different answers. It's going to be up to us to decide which of these is really accurate. Start with the first hit. Where's this from? Cornell.edu. Cornell University has something relevant to this topic. This looks pretty good. Read through this and see for yourself. Is this helpful? Does this explain anything? What else can we find? Quora is an excellent resource where other users will help you by applying their critical thinking skills to the various answers to these questions. And then you could use that to help judge. At least, certainly, you'll get what the most popular answers are. What's this? Physics, Stack Exchange, Astronomy. Here you're going to get, again, this is an ask on the internet type of location, so it doesn't guarantee these answers are right, but there's lots to read and learn from. And what's this right here? This is something I find interesting. The moon tilt and terminator illusions. What's useful about this particular link is it has taught us a new vocabulary word. The vocabulary word is terminator illusions. That itself may help us to find the answers we're looking for. If we speak the same language, we'll be able to get better answers. So, look at this. Easy to understand explanation of the moon terminator illusion. And here's one that looks like it's VSauce. I'm a big fan of VSauce. You can check him out. He does really fun pop sci stuff. And here's Wikipedia on the subject. Let's check out what Wikipedia has to say. So, what is a terminator? Why are we even talking about a terminator? Again, this is vocab. You can read that later. Let's look the lunar terminator illusion. That seems to be what we're talking about. And they have all of one line on the subject. But this is the part I find interesting. The cause of the illusion is simply the observer not taking into account that the observed slope of a light ray will change across the sky because of the lack of visual cues to establish 3D perspective. And there's two links there. Well, that's like a lot of words. That's a whole lot of words. The keys are, it's an illusion. And it has to do with the observer not taking into account blah, 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 blah. The observer is not taking something into account. Does that sound familiar? That sounds very much like our option C, which was maybe there's a detail we're overlooking. Something I like to do when using my Google searches is go straight to the images. A picture is really worth 1,000 words. By looking at these pictures first, it can guide us to what we're really looking for, and then we can read the contents. From here, we can see very plainly that this is exactly what we're talking about, right there. This is exactly what we're talking about. In fact, this image looks strikingly like an image that was linked to me in the Flat Earth Society by a flat earther. This is a diagram that supposedly shows this rhetorical question. Can you draw a diagram that explains this? Here's the sun, here's the earth, here's the moon. And this is what we were seeing in those videos, that the moon is pointing up above the light source. It's not pointing down to the light source. And the flat earther asks the rhetorical question, can you explain this? Well, again, you can't go to the flat earther to get the answer to this question, but if you ask someone who's knowledgeable about science and astronomy, I think maybe you can get an answer to this question. In fact, let's see if any of these has something like that. How about this one? What have we got here? We've got a man holding a ping pong ball up to the moon. Our takeaway here is that the way the moon looks with its lighting, with the light on the right-hand side and the darkness on the left-hand side, matches the ping pong ball's lighting. And that is exactly what we'd expect because they're both being lit by the same sun. If the sun is over here, the ping pong ball is lit over here. If the sun is over here, the moon is lit over here. This is a fantastic demonstration, and this is what I encourage you to do yourself. We can cut through all of the competing arguments. Who says what? Who says why? What's the explanation? Is it fake? Are we being lied to? Well, I'll tell you what can't lie to you. If you walk outside and you hold up a ball, you can see with your own eyes. No one can fool you. No one can lie to you. This is the truth. All right. So we've learned that this phenomenon is called the moon terminator illusion. And in order to better understand exactly what that is, let's make a three-dimensional simulation, a diagram in 3D. Let's go over here. This is the situation we want to try and create. The moon is on the left and the sun is on the right with the observer in between. And here I've created a three-dimensional simulation of this in Unity. Unity is a free package. You can download it yourself and do something like this. It's very easy to use. I have the sun, I have the earth, the camera is the observer on the earth, and here's the moon. Thought you might get a kick out of this. I've modeled the earth as a flat disk. This simulation is not to scale. It does not need to be to scale in order to see this effect. I just wanted something to provide a horizon line. This is the scene view here. I can look at it from any angle. I can zoom in and out. This view is the camera eye view. So I have the horizon line and I'm looking up at the moon. In the scene view, you can see where the camera is looking. You can see the camera is set up looking at the moon. Right, there's the earth, there's the moon. Camera's looking up at the moon. There's the sun. Okay, so here's the moon up above the horizon. And this is a horizontal rotator that I've hooked up just so that I can rotate this whole camera view to the side without changing the angles at all. So I can, without changing the vertical angle at all. I keep the horizon right level and flat right there. as I rotate over to find where I've put the sun. Oh, there's the sun right there. Here's the moon. Here's the sun. I've put the sun setting. The sun is setting. It's crossing below the horizon line. And you can see that right here in the side view. The sun is a little bit below the horizon. And there it is. Okay, so back to the moon. What do we expect? We expect in this diagram that the sun's light will shine up onto the moon. And the sun being down on the horizon, the moon being up above the horizon, we're going to expect the light to hit right here. All right, so let's put that expectation to the test. I put a light on the sun. Let's turn it on. We expect the light to hit, bing, right here. And you know what, before I do it, let's zoom in on the moon here in the side view. We're going to expect it to hit right here, pointing down towards the sun, so it's going to hit right about there. And that's going to be right here in this view. So look at this. The light is hitting right about here, a little bit below the center line of the moon. But in this view, this is clearly above the center line. The light is pointing up and away from the sun. This is exactly the situation. Let me kick it up just a little bit so you can see that flat earth there. This diagram is this one. Here's the sun, the earth, and the moon, only just like you'd expect, the moon is not lit like this. The moon is lit pointed straight at the sun. The moon is lit pointed straight at the sun, but it is in this view, for some reason, the light has hit at the top. So let's look over at the sun again. There we go. There's the sun. I'm going to pan back and forth. Moon, sun. This is just like the video shows. You look at the moon, the light is pointed up. Pan over to the sun, and the sun is down low. Like this. You look at the moon, and the moon is pointed up. You look at the sun, and the sun is down low. To help illustrate exactly why that is, I'm going to draw a visible line going from the center of the sun right through the center of the moon. This straight line, I'm going to draw a straight line in 3D through the scene to show the direction that the light goes. There you go. There's a beam of light coming through the sun, boom, going right through the center of the moon. And here it is. Here it is in our simulation, coming from the sun, pointing straight at the moon. This is our light. Now let's look back over at the moon. And lo and behold, that straight line pointing straight from the sun towards the moon is not coming from the bottom of the frame. It's coming from the top of the frame. But I didn't move the line. The line is still pointing straight from the sun to the moon. But in this view, it's coming in from the top of the frame. Let me rotate the view slowly, and let's see what happens as I rotate the view. Slowly rotating. Notice how the beam is tilting downward. It's tilting down. It's level. It's about level. As I continue rotating, it tips now down, and now, boom, as the sun comes into frame, this line is now pointing, from the sun, it's pointing upward. From the sun, it's pointing horizontal. From the sun, it's pointing down. As I rotate my view, this line goes from pointing up to pointing down. And the only thing it takes to do this is rotating my view. That can be a little hard to understand still, but what we're seeing is perspective. This is the perspective effect. Let's look at the setup view, the scene view here from a top down, and watch what happens as I turn my view watch what's happening to the camera's view. These white lines are what the camera can see. Camera is looking at the moon. We rotate. Watch how the view on that line is changing. Here, the line is cutting through the camera view, right? We're standing here looking along a line, and the line fades away into the distance. And here, we're standing here looking along a line, and the line is fading away into the distance in the opposite direction. Look at that. That is why the line appears to be angling up away from the moon here in this shot. It's not angling up away from the moon. It's pointing straight towards the sun. This is the direction straight towards the sun in 3D. And now maybe you're saying to yourself, this is a trick. This is some kind of weird fisheye lens effect. This isn't real. This isn't what really happens. But it does. And I can explain that really simply. Let's do this. Let's get rid of our horizon plane. We don't need the disk. And let's instead bring in a railroad track. So what have I got here? I'm going to zoom in. This is two parallel lines. This is our railroad track, and it goes right next to our viewer. So the viewer is looking along the railroad track here. Let's bring that more into view. There's our railroad tracks. We're standing next to the railroad tracks, looking. Now, what do you know from your own experience as you look along railroad tracks? They look like this. Right? They get closer together, and they move up towards the horizon line. And then as we rotate the view, now we're looking along the railroad tracks in the opposite direction. And so they get closer together and they move up towards the horizon line. So this is what we know that railroad tracks are supposed to do. You've seen this before. This is just perspective. The lines converge towards a vanishing point. And here the lines that converge towards a vanishing point. So consider, we were okay with it when it was railroad tracks. We understood that even though the railroad tracks, we know they are parallel, they appear to be aimed up. They appear to be aimed up towards the horizon in the distance. And as I rotate the view, the railroad tracks seem to rotate so that they are once again aimed up. So when we take a beam of light in the sky above our head, it's going to do the exact same thing. Only now it's above us, so it's going to be aiming down towards the horizon. And as I rotate the view, the beam of light has to rotate as well and aim down towards the horizon. So there you have it. There's my simulation to show exactly what's causing this. Now the next step ought to be, I would say your next step ought to be to verify that this is really representative of what happens in the real world. Is this not some trick of the simulation or some fault or breakdown in the math that's generating this simulation? Let's take it out into the real world and take pictures. So here I am outside. I'm going to take my own video. There's the moon being lit from the left this time. This will be a sunrise, and the light is very high on the moon. The light seems to be coming down from the top. Here's the sun rising over the trees. And so what I do is I hold up a ball, just hold up a tennis ball in the same, orientation as when you're looking at the moon, and compare. Is that really how the light should be coming from the sun? And you can see here that the lighting on the ball is very similar to the lighting from the moon. Look at that. The direction of the sun from this angle is up and to the left. The only deception was my own expectation that the light should be on the bottom of the ball. The light's not supposed to be on the bottom of the ball. Light is on the top of the ball. So there you have the moon terminator illusion, a very fascinating aspect of the natural world. It's very real, and the explanation was interesting. And we've used this as an illustration of how to avoid the pitfalls of really poor critical thinking. And this individual is a case in point. He starts from an excellent standpoint, which is that the moon does not always point directly at the sun, and goes on to say that it is hard to imagine there's any explanation for this. Well, it may be hard for him to imagine it, but it really wasn't very hard for us to find the explanation for it. In fact, the explanation was given within this very thread right here. And yet still, after 16,000 posts over the course of 11 years, where he is supposedly researching flat Earth, he still has never seen this explanation before? Despite them having been linked to him before, despite how easy it was to search for them, he's never seen the explanation from VSauce of the moon terminator illusion. He's never seen this demonstration where someone in a garage sets it up and shows exactly how it works. And with all that, I'll leave you with this little gem that speaks for itself.